The midpoint theorem, a fundamental rule in geometry about a beautifully simple idea. What happens when you connect the midpoints of two sides of any triangle? The answer is always the same. No matter which triangle you pick, the connecting segment is always parallel to the third side and always exactly half its length. Let's explore this step by step. The theorem statement. In triangle ABC, let D be the midpoint of AB and E be the midpoint of AC. Then two things are always true. First, the is parallel to BC. Second, the equals exactly 1/2 of BC. Watch as I mark the midpoints and draw segment the. Then place it alongside BC to show the length comparison. The tick marks on AD and DB confirm D is the midpoint of AB. The tick marks on A and A confirm E is the midpoint of AC. The double tick marks on the and the right half of BC show that the equals BC over 2. The converse of the midpoint theorem. The theorem also works in reverse. If you know only that D is the midpoint of AB, and you draw a line through D that is parallel to BC, then that line must hit the other side AC exactly at its midpoint, which is point E. The converse is just as powerful as the original theorem. Both directions together form an if and only if relationship between midpoints and the parallel condition. Proof via congruent triangles and a parallelogram. Step 1. Extend the to F so that EF equals the. Step 2. Draw CF. Step 3. SAS gives triangle AD congruent to triangle CFE. A equals AC, midpoint. Angles AD and CEF are vertical, and the equals EF by construction. Step 4. The congruence gives DB equals CF and DB parallel to CF. So DBCF is a parallelogram. Step 5. In a parallelogram opposite sides are equal and parallel. So DF is parallel to BC. DF equals BC. And the equals BC over 2. QED. A beautiful application. Varignin's theorem. Take any quadrilateral, any four-sided shape at all, even a completely irregular one. Mark the midpoints of all four sides. Now connect consecutive midpoints to form an inner quadrilateral. By the midpoint theorem applied twice to the diagonals of the original quad. Each side of the inner shape is parallel to a diagonal and half its length. Therefore, opposite sides of the inner shape are parallel and equal. The inner quadrilateral is always a parallelogram, no matter what the outer shape looks like. This is Varignin's theorem, and the midpoint theorem is its engine. Summary of the midpoint theorem. The main result. In triangle ABC, if D and E are midpoints of AB and AC, then there is parallel to BC and equals half of BC. The converse. A line through a midpoint parallel to the base hits the third side exactly at its midpoint. The proof constructs point F by extending the. Proves triangle AD is congruent to triangle CFE by SAS. Then shows DBCF is a parallelogram. And the beautiful application. Varignin's theorem says that connecting the midpoints of any quadrilateral always gives a parallelogram.